Video is for my radon sensor. I thought I'd document this so I have proof of concept. Here's my ionization chamber. I'm powering it right now off of a 12 volt DC power supply, external, connected here at what was set up for a 9 volt battery. It goes through 555 timer, voltage multiplier, and then through this BJT Darlington transistor here on the bottom side. You can see it. Let's see if I focus. Alright. The collector of the BJT is attached to ground here right now with 12 volts. On the DC supply there's 50 volts provided on the output of the multiplier. 50 volts. It's attached to the outside of the ionization chamber, and then here this blue banana jack is attached to the cathode on the inside of the ionization chamber. We have the Darlington acts as an amplifier for the output here, the current, when the alpha particles from my isotope here, there's the americium-241 isotope from the inside of a smoke detector. It gives off quite a fair amount of alpha particles. You can see my detection circuit lights up when alpha particles from the americium are picked up by the cathode. Alright, the rest of the circuit here. So, I wasn't able to connect this to my microcontroller for digital detection with my original way of measuring current there. Well, you don't have to go into the details on this video. What I did was took this current monitor, this little device here from Adafruit, has an INA219 IC there, and it uses that shunt resistor. There's a 100 ohm shunt resistor on there, and it goes in series with this other PNP Darlington. I'll show you the schematic, not in this video, but again, when the isotopes are present, the circuit is completed, the BJTs provide enough current to light up that LED. This INA 219 is not sensitive enough. It's not sensitive enough to pick up the current that's going through there. Here. Alright, so we're gonna go put this on here. You can see it's lit up. What it does detect is the voltage. There. You can see the bus voltage is now up to almost the supply. Let's see if I keep the isotope close enough to the inside of the ionization chamber, but the resolution just isn't there. You go down to, hundreds of microamps. What I'm seeing here experimentally with my multimeter is I'm in about 30 microamps, so I'm just outside of range. With a better chip here, I would be able to detect that, and there are some, I've actually got some parts that will go down to the microamp range. So there it is, proof of concept at least. Yeah, this is going to be extremely difficult to calibrate. I would need at least one other isotope, so I could get a baseline for what's actually going on in the circuit here.